Hello everyone. Let's provide the complete solution to this problem. Okay, so what do I do in this case? It's simple. We add what we have right here. So if we do that, we have 2 of 3 to the power of x equals 3. And then the next step is to divide both sides by 2 so that this will be moved. And then we have 3 to the power of x alone, which is now equal to 3 over 2. Now the question is, how do we get our value of x? To get the value of x, we will take the log of both sides, since we cannot express this in this form. So we'll now get log of 3 to the power of x equals log of 3 over 2. If we go ahead from here, we're going to have x log 3, since the power always goes behind. Then on the other side, we're going to have log of 3 over 2. Then we are going to apply another law of indices to what we have right here. Is it law of indices or law of logarithm to what we have right here? So that we have x log 3 equals log of 3 minus log of 2. Okay, if it is division between them, you subtract the logs, and if it is multiplication, you add the log. Now we can get the value of x by dividing all through by 3, right? By log 3. So we're going to divide this by log 3, divide this again by log of 3, then divide this by log 3. This is going with this, and this is also going with this, meaning that x is left on the left, and then on the right we have 1 minus log 2 divided by log 3. So what I will do here is to change the base, apply change of base, so that x will be 1 minus log 2 to the base of 3. This log 3 here, this 3 here becomes the base of the numerator, provided both of them are in the same base. So this is what we have as the value of x, and we always verify our work. So let's see whether this is correct. We got 3 to the power of x plus 3 to the power of x equals 3. Now what do we do? This is so we now have 3 to the power of, in place of x, write 1 minus log 2 to base 3. Then plus, we have the same 3 to 1 minus log 2 to base 3. Now, if we add these two, are we going to have 3? Because we had 3 on the right hand side. Now, to this alone, we are going to apply a law, okay, of indices that says if you have x to the power of a divided by x to the power of b, this is the same thing as x to the power of a minus b. Okay, so you will have to divide, if you're dividing, you subtract the powers. So that is the same thing that happened here before they got this. So we'll take this from this form to this form, and then we'll now have 3 to the power of 1 divided by 3 to the power of log 2 to base 3. So that if you pick one of the bases, you will subtract the powers and it will give you this, okay? Plus, we'll do the same thing and we get 3 to the power of 1 divided by 3 to the power of log 2 to base of 3. Okay, so from here now, remember that 3 to the power of 1 is the same thing as 3. Then divided by this right here, 3 to the power of log 2 to base 3. This is considered the base, right? And this is the exponent to the same base here. Okay, so since it's log 2 to base 3 and it is the same 3 that we had here, this and this can go. So we will now work with 2. Then plus on this side, we still have 3 to the power of 1 and it's 3. Then divided by here again, we are going to have 2 because this is 2, this is 3 and that is 3. So from here now, we can even arrange this in another way so that we get 3 over 2 plus 3 over 2. This is because we are to carry out the division before the addition. So now we have carried out our division. So you now find the LCM, which is 2. Then we have 3 plus 3. For those of you that must have forgotten, the LCM of 2 and 2 is 1. 2 divided by 2 is 1 times 3 is 3. 2 divided by 2 is 1 times this 3 will give us that 3. And at the end of the day, we are having 6 over 2. And 6 over 2 is equal to 3. Remember the equation, we got 3 to the power of x plus 3 to the power of x equals 3. So because we have 3 here, it means that our value of x, which is equal to 1 minus log 2 to base 3, is satisfying. Thank you for watching.